I think we can start now, Pak. 37 and almost 40 student participants join with us. Yeah.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Hello, Prof. Walter.
Yes, hello.
Okay.
Yeah. Sorry
Can
for
we
this.
Start now?
Yeah, we can start.
Okay.
So, can I share my screen?
No, but I have to open this lecture series, and then you can present your material after this opening. Okay, good morning, everyone. Today is a very special day because we have to distinguished professor, the Honorable Professor Walter Timon de Vries, and the Honorable Professor Dr. Renat Imam Bukhari. Good morning. This morning event is a continuation. This is the third in international lecture series after the previous two were held a few weeks ago. And now we have the theme of land management and GIS. And before starting the lecture series, allow me to read the CVs of the following two professors. The first one is Professor Dr. Walter Timon de Vries, born in Germany in 6 June 1965, and the current position he is a chair of land management and dean of studies geodesy and geoinformatics, and director Center for Land, Water, and Environment in Technical University of München, or TU Munich. The current activities is the dean of studies geodesy and geoinformatics, and also member of Faculty Council, Faculty Aerospace and Geodesy, and also member of Decanate Faculty of Aerospace and Geodesy in Technical University of Munich. He got the PhD for Public Administration in Erasmus University Rotterdam in Netherlands, and the degree is for in 2008 from the several universities in the Netherlands. So the second presenter, Professor Dr. Renat Imam Bukhari. Yes, he is one of the outstanding professor in urban regional planning in Indonesia. He was born in Temanggung, 23rd November 1970, and now he is a professor in urban regional planning. And he have a lot of experience, starting from 1995 as a lecturer in the Department of Regional Planning, and then in the 2008 until 2012, he is the chairman of the Department of Urban Regional Planning, and until now he is have a strategic position in the National Accreditation Agency as Secretary of the Accreditation Council. So please welcome Professor Walter Timon de Vries and Professor Dr. Renat Imam Bukhari. And the first one, in this very special occasion, Prof. Walter de Vries would like to present his research with the title Land Management and Geographic Information System. So time and screen is yours, Prof. Walter Timon de Vries.
Okay, thank you very much. I will share my screen. Hope that it's visible now. Just to confirm.
Yeah.
Yeah. Okay, good afternoon. From the Technical University in Germany. It's my pleasure to be here, and also thank you again for the invitation. I would like to talk about the relation between land management and geospatial science, or land management and geospatial information systems. And the agenda is as follows. First, I would like to say something about what is actually land management and why do we need it. And then I'll go into the sort of classification of land management activities and maybe related to spatial planning. And then talk about some new, old and new trends in geoinformation sciences, technologies, models, and methods. And in order to end up with, okay, how is GIS and geoinformation science relevant for land management? Well, let's first of all start, when we talk about land management, about some basic statistics. When we would divide the whole world to all the people that are existing on the world, then we would end up with 50 meters for every. I checked this morning, or actually yesterday, how many people are on this planet at the moment. It's about 7.8 billion. And the total area, we can take the total area if we calculate that, but the total arable area is actually what we're interested in. How much land can we actually live on or live from? And then we end up with this calculation with about 50 to 50 meter. Now, if we know that many people have actually much more than that 50 by 50 meter, which is a quarter of a hectare, we also know that we actually need living or agriculture, then we can immediately feel that somehow the division of land is not equal in this world, and it is for land managers to do something about that. Another statistic I would like to take from the German context, and that is the statistic of land take or land conversion. Up to 2017, about every day, some 58 hectares was reallocated and converted from agricultural land into non-agricultural land. It means that every day, almost 60 hectares is taken from the arable land and from fertile land. So that is a dramatic, actually, conversion that is taking place. And also, if you think about that, quite dramatic for food security in the long run and also for a place to live. People have recognized that in Germany, and for that reason, they came up with a policy to limit that to 30 hectares per day by 2030, but up to we need to somehow limit the amount of land conversion that is taking place, so to provide for land in a responsible and acceptable manner. We also need to seek appropriate solutions to avoid the negative effects of that land take and land conversion. And we need to provide at the same time sufficient and affordable space for everyone to live and to work on. So this is a major challenge for it's sort of the spatial nature of a number of phenomena that are manifested, but also the socio-economic on the one side and the legal institutional context on the other side. And that's why we also need a set of comprehensive tools and instruments to redesign the division of land. Now, and therefore, I would say we need two types of concepts. On the one hand, responsible land management, and that is a set of theoretical and normative concepts of land management. Smart is not just technologically supported, but also smart in the set of intelligent tools. So essentially, divide the land in a responsible manner, such that it is not in the hands of a very few and the others are suffering. And on the other hand, we need all sorts of instruments and tools, such as geoinformation tools, to redivide the land. Here we see a couple of those tools. Handheld instruments, tools to readjust land, and also the tools of digital twins, and I'll come back to that later. So what sort of activities are we actually working on as land managers? And here I've categorized them in 5 categories. First of all, it's the spatial design and the spatial structure. And that includes things like master planning, physical planning. And that's especially relevant for the urban context. And in the rural context, and population or
Pak Walter have a problem with his connection, maybe Mas Imam
Hilang ya?
hilang.
Masih ada Bapak, tapi belum itu. Masih ada di partisipan. Nah ini baru keluar nggak ada.
Oke, kita tunggu lagi aja sebentar.
Ini ada, udah masuk lagi.
Ya.
Okay, it seems back. Yeah. I hope you can hear me again and see it
Yes.
again.
Yes.
Okay, sorry, I was on the issue of urban light. Light is one of those things such as or increase of informal settlements. So these are things that I'm sorry for these breaks. I hope it's good. The 4th and 5th category, let me continue with that, is on the one hand compliant version, is how do you actually make sure that things are happening? Mobilization component of land management. Just to come back on this spatial structuring, we've done a recent, or we're still in the process of looking at land consolidation. And typically land consolidation is about defragmentation. So on the one hand, you need to come up with good and usable land, but defragmentation is a crucial component of land consolidation. But we actually that in the ownership, but
Nge-lag lagi.
Atau kita pakai recorded aja ya.
Ini masuk lagi. Wah, iya.
Ditanya aja ke Pak Walter.
okay, I'm sorry, I'm not sure why this is happening. Good.
Pak Walter, if you face more problem, I think it's better for us to use second option. for your recorded video.
Yep. Yeah,
But-
I've recorded a video. I'm not sure where the problem lies. You notice that there are some internet problems. We've been experiencing that for the last week or so.
So
It's up
okay,
to you.
let's us continue with your presentation.
Yeah. So I was talking about spatial structuring in the rural sense. Land fragmentation and defragmentation is an important issue, but also in the urban setting. Spatial design deals with designing new cities, for example, from scratch. And secondly, it is also spatial redesign. So here you see coincidentally the area on the bottom where I'm currently staying. They are redesigning this place and building and rebuilding a number of houses. The second category is spatial monitoring. You can do that on a global scale, a national scale, or a local scale. What you see here is two examples of one of monitoring on a global scale. Where you monitor how much forest is being deleted, or where deforestation takes place, and what comes instead of that forest. And the other one is the Atlas of Informality, which is a project that works on where are informal settlements occurring and how much are they growing or decreasing, and what are the characteristics that are in those informal settlements. So monitoring is a crucial component there. Administration of there, typically we deal with cadastral systems, traditionally that are paper-based systems, registration and making of cadastral maps. Here you see two examples in the German context. A lot of that is still happening paper-based, even in Germany, because people only trust paper to a large extent in Germany. But gradually, we also see a conversion into more digital systems, 3D systems, even 4D with time component and 5D other components. And in addition to that, you see different types of cadasters emerging. A cadaster of empty spaces, empty houses, empty land, a cadaster of restrictions, and water cadasters. And another category of land management is compliance and coercions. Now, on the one hand, there is the compliance to housing permits, for example, or building permits, and how you make use of land and buildings. Now, that is systematically recorded. On the other hand, you can also have more on the other side of the conversion. Where is people are evicted, or where is it that people are penalized or sanctioned, for example? The eviction lab is a nice example of the types of evictions that are taking place, where people have to be relocated or people are no longer in possession of a house. Then there is the participation and mobilization. On the top hand, you see the Improve My Neighborhood map, which is a platform where people can indicate certain problems they may have, and the idea that government would solve those problems. So the red pins are a problem, and the green pins is so the government has solved those problems. That helps as a sort of overview, where are the problems occurring, and secondly, if the government is also doing something about it. And the second example is from the Philippines, where people have uploaded problems with criminal activities. So that also to show, okay, here the government needs to do something, but also for citizens themselves, oh, please don't go to certain criminal problems. So if we look at the technologies that are available, then to support, I would make a categorization of 5 types of technologies. The first type is the integrative and analytical technologies. This is typically what we understand with GIS. You can do analysis through buffering, through intersections, through overlays, And the idea that
Okay, Prof. Walter.
yeah, am I back again? Sorry.
Sorry if you have a problem. Can we start your video or your backup presentation here?
Yeah, maybe you can indeed. Sorry for this. I'm not really sure why this occurs. Yeah, maybe you can do the recording, and I will be available for the questions.
Okay.
Yeah.
Okay, Prof. I will share your video and your presentation through this Zoom meeting. Okay, Pak Imam, can you help me to show Prof. Walter presentation through the video?
Oke, Mas Agung.
Yeah.
Hello, my name is Walter de Vries. I'm from the Technical University of Munich in Germany. And today's lecture is about land management and geospatial information systems, or GIS. We can also say GIS, geographic information systems, but I'll talk about more about geospatial applications and geospatial types and examples. So I'll share my screen for this presentation. I hope you can see that. Yes, the agenda for today is, first I want to introduce why land management and how is it related to spatial analysis and geospatial analysis and geospatial information systems. Then I'll talk about some activities and research endeavors and goals and practices of land management and how they have a spatial component. I'll talk about a little bit about how to classify GIS systems or technologies. And then I'll go into a number of applications. So where you can clearly see that there is a relation between land management and GIS or geospatial information systems. So let's first talk about why land management. And I want to do that on the basis of two clear statistics. If we look at the total amount of land in the entire planet, we can say, well, we can calculate that, how much that, that space is. But on average, the total area is about 1.4 times 10 to the 8 square kilometers. That would include all land that there is available, including land that is actually not habitable, such as deserts or mountainous areas. So the total land per person you could actually calculate. But imagine that there's only about 13% of that area is useful as arable land. So land where you can actually grow crops. And if you take that portion of the earth and you divide it by the number of people that actually live on this planet, and I checked it this morning, it was 7.8 times 10 to the 9th, or 7.8 billion approximately. Then you can calculate that you have about 50 by 50 meters per person if you would divide the Earth's arable land equally. Now, we all know that many people have much more land, and we know that the land is not equally divided. So we can clearly say there is a need to do something with that land, or the division of that land. A second statistic that I would like to introduce is a statistics from Germany, is that during the last 60 years, the settlement and transportation in areas in Germany has more than doubled, meaning that actually the land allocation or the conversion from arable land or agricultural land into non-agricultural land, such as infrastructure, built-up industry area, has increased dramatically. And the statistic is that in 2017, around 58 of hectares was redesignated every day, mostly at the expense of agriculture and fertile soils. Now, this corresponds roughly to the size of 82 soccer fields. That means that actually you use a lot of arable land in the country. Now, there is an idea to reduce that. There's a policy to reduce that to 30 hectares per day by 2030. And we look at the statistics, actually, it is not doing so well. There is indeed a decrease to reduce, an idea to reduce the amount of land take that is taking place. So, but that is still far beyond the policy objective. So essentially, that means that the amount of land that is available for arable land that is available for agriculture to grow crops is definitely decreasing in favor of urban expansion, for example, industrial expansion and infrastructure expansion. So that's why we need land management. On the one hand, we need to redesign land beyond the 50 by 50 meters in a fair, responsible, and acceptable manner. And we need to contribute to finding solutions for avoiding the negative effects of the land take, or the land grabbing, the urban expansion, which and the negative effects of that are food insecurity, unusable land, etc. And last but not least, we need to provide sufficient and affordable space for everyone. So land management is doing that, and it is doing that on the basis of two premises. On the one hand, we need an understanding of the spatial nature of the land expansion or the land reduction. We need to understand in which context that is taking place, socio-economic, legal, institutional context, and organizational context, which organizations are responsible. And on the other hand, we need a comprehensive set of tools, methods, and instruments to redesign, reinvent, and intervene in the current situation. So we need to have land management interventions which are useful. Now, in order to do that, on the one hand, we need theoretical models and normative concepts about how to redistribute land. So we need to understand what responsible land management is. And secondly, we need methods and tools which can be used to design new redistributions of land. So, and that I usually refer to as smart land management tools. So division of land needs to take place in a responsible manner, such that the space is divided fairly, appropriately, such that everybody has an equal chance to make use of the space and also an equal say in making use of the space, and not just that few people can decide. On the other hand, we need to distribute it with tools that are currently available, technological tools, management tools, smart tools that are currently available. And there, geospatial sciences, geospatial tools, GIS plays an important role. Here we see already some of those applications, mapping technologies, handheld technologies, decision support technologies, technologies that can actually calculate the redistribution, and also digital twin technologies. I'll come back to that one later. Now, how does that fit in the general sequence of land management? What do we actually do within land management? Here's some sort of classification, which I think is useful. What are the practices in land management? First of all, there is the practice of spatial structure and design. You can say that is overlapping spatial planning to a large degree when we talk about master planning, physical planning, spatial localization, and land use zoning. But very specific for land management or land readjustment are the practices of land consolidation, land redistribution, finding urban development boundaries, so how far can the city actually expand, and discussions about urban form and urban shape. The second part of land management is the monitoring and the assessment. What is actually taking place and how can we do that? For example, land use change detection. Where are certain land uses taking place? where is the city expanding? Which parts of the cities are green or should be green, and how much is that fluctuating over time? Issues such as urban blight being sort of ghetto forming, slumification that are taking place in the city and the like. Where are informal settlements growing? That is a typical monitoring tasks. Then there is the administration of land, or the administration of properties, land administration, you can say, such as land registration, land recordation, also valuation of land, issuing spatial restrictions, administrating customary or communal land or adat land, land grabbing, monitoring land grabbing, and conservation of cultural heritage, administration of cultural heritage buildings and locations. The fourth category is the compliance and coercion category. How do we issue housing permits, building permits? Where do we issue sanctions or penalties? And also in the COVID area, we've seen that there were actually quite a number of restrictions. On the one hand, there are these spatial restrictions. Where are you allowed to go at which particular point in time? Secondly, there is also the policing of those restrictions. So what sort of penalties do you issue at which point in time and in which particular place? And sometimes that also leads to evictions or relocations. If people settle on areas where they're not allowed to settle, or where there is a different plan, or where the owner doesn't agree, then there needs to be an eviction or a relocation. And finally, there is the issue of participation and mobilization, especially in the land use planning, in the designing of new cities, in the designing of new spaces. That needs to be built on stakeholder analyses, on handling of complaints if people agree or don't agree, on a collaborative design, and essentially also on community participation. So let's look at some examples of that. First of all, in the rural sense, there is land consolidation. We see, and this is from a study that was done recently, that there's actually quite a number of different types of fragmentation of land, especially rural land. That is not just fragmentation in the form of shapes and sizes of the land, but also fragmentation of ownership, fragmentation of usership, fragmentation of joint ownership and joint usership, shared usership, and the like. So this study actually identified 40 types of fragmentation which occur. And in the redesign, so in the land management redesign, you need to incorporate all of those types of fragmentation in order to come up with a new land use plan, land consolidation plan. And that in itself, if it is only one type of fragmentation, namely ownership fragmentation, is usually already complicated enough, let alone if you have 40 types of fragmentation of land. Now, this also takes place in urban areas. So it's not just a problem of rural areas, farmland, but also urban areas. If you redesign urban areas, you also need urban readjustment very often. And that basically is founded on the same set of principles, a readjustment of size, a readjustment of properties, also in consultation with the various stakeholders. Again, if there's various types of fragmentation, you need to find methodologies that take all those types of fragmentation into account. The second category is the spatial design, so the spatial restructuring. And that is especially for urban areas, because that is where most of the structuring takes place. In rural areas, you also have spatial designs, of course, even in a land consolidation plan. If you bring in new roads, new railways, new waterways. But urban design is especially prominent. Also part of land management. So if you design an entirely new city then you need to design all the elements of the city. And all the elements also need to be underlaid with new boundary structures and new ownership and use structures. It could also be a redesign of an existing urban area, but there you start completely anew. So, for example, you destruct all the existing structures or buildings, and then you create new buildings. That also would mean that you need to redesign and readjust the amount of space. On the monitoring side, there's many maps that you need, obviously, and many maps that are available. Monitoring actually takes place at all levels. You can monitor, for example, globally. There is, for example, the Global Forest Watch organization or NGO that monitors how much forest and how much deforestation takes place at which particular place, and what it is replaced with. So the Global Forest Map and also that website is quite extensive. It's not just deforestation, but also land grabbing or conversion of land, conversion of agricultural land into non-agricultural land, etc. Quite an extensive global monitoring site. At the same time, there's also many websites that show spatial information about local areas. If you go, for example, to the Atlas of Informality, you find a number of cities which are being monitored for how big or how large the informal settlement areas are growing. Quite a useful site, also an interesting project to see how fast informality is actually growing. And they discovered that actually informality is growing much faster than structural design of new cities. The fourth category was the administration of land. And there we talk typically about cadastral registration. The typical cadastral registration is based on registration of rights and registration of property boundaries. Now, in the traditional form, that was purely a 2D exercise. And also you saw that there were only 2D paper-based maps. In many countries, it is still like that. But we see increasingly that these maps are digitized or made directly in digital form. And we also see new types of cadasters arising. 3D cadasters, where you also have the third dimension, the height dimension, 4D cadasters, where you have the time dimension, and 5D cadasters, where you have all sorts of dimensions and thematic areas connected to the basic information. You also see that there are not just property cadasters that register rights and value and land tenure, but also cadasters of vacancy. Where are empty houses, for example? Where is unused fields? There are also the emergence of public rights and restrictions cadasters. So not just the rights to the plot or to the building, but also the restrictions of certain areas. Also spatial restrictions, of course. And besides the land cadasters, you also have water cadasters, for example. For the issue of compliance and coercion, you have traditional systems such as the housing building permits, and also all sorts of permits, what you are allowed to do in the house or from what sort of structure the house is built. And there's also a number of sites which show, for example, evictions in particular areas. So where are evictions from houses or from land taking place, and is that also a rightful eviction, or what are the effects of these evictions? So information systems, spatial information systems that deal with land management issues. Where are you allowed to live? Where is land available? Where are people moved out of land, etc. And finally, for the category of participation and mobilization, we see an increasing number of websites that are constructed bottom up, so by the local populations themselves, who, for example, aim to improve the neighborhood or collect for themselves criminal activities. Where are they taking place? Where are areas safe? Where do we feel safe, and where actually do most of the criminal activities take place or accidents take place? These are things that people can load up by themselves and then also make them available on the internet so that they can be shared by with everybody, so that people can see on their own mobile phone, or if they do an extensive spatial analysis on their laptop or on their computer system, so that they can do a spatial type of analysis. So what sort of technologies are then available to do those type of analyses? And again, here I would like to make a categorization. I would say there are 5 types of spatial technologies that we can actually make use of. And we'll also see that there are gradually changes in each of these types of technologies. The first type of technologies is something that most of you may be familiar with. These are the sort of integrative and analytical technologies. Essentially, in geospatial science, there we talk about geographic information systems in general, the traditional geographic information systems with which you can do overlays, intersections, network analysis, buffering, these type of operations. And the idea behind that is to detect and deduct locations. Where is something taking place? Spatial patterns. Where are maybe certain phenomena taking place, or what is the reason behind certain spatial phenomena? And to detect spatial clusters. So other hotspots of particular activities or of particular phenomena. The other type of GIS is essentially to register, record, and allocate properties to spatially distributed artifacts and objects. So one of the most common GIS system is actually land information systems, if you want to assign rights or restrictions to certain objects. Another type is to assign values to spatially different or environmental problems to certain objects and artifacts. The second type of data acquisition or the second type of GIS is data acquisition technologies. And there we talk traditionally about surveying, photogrammetry, remote sensing technologies. And the idea behind those sort of technologies is to establish reliable and accurate georeferenced foundation data or geodetic networks, to derive geometric descriptions and classifications of objects, and to acquire systematically georeferences during navigation or for navigation purposes. So these are technologies that either directly or indirectly discover a particular georeference. The third type of geospatial technology is the smart and artificial intelligence technologies. Traditionally, these were the spatial decision support systems, planning support systems, and very often in the past, both spatial decision and planning support systems were GIS systems in combination with spatial decision support tools, such as multi-criteria analysis or AHP, analytical hierarchical processing. So these are methods or tools that are not necessarily spatial by themselves, but in combination with GIS, you can, for example, make a decision more easily, where to locate certain things, or where to go, or where to extend an urban area, for example, based on multiple criteria, which then you weight against each other. Nowadays, what is added to these sort of decision support systems is the possibility to connect it to multiple sensors, surveillance technologies, so sensors that are in the ground or on buildings or in machines or moving things that actually generate data by themselves and automatically upload that into the decision support system, and then give a particular advice on which decision to take. And if you extend that a little bit further, we go into machine learning and artificial intelligence technologies that can autonomously generate new results and new scenarios, and independently even derive and execute decisions. So nowadays, it's not just anymore just collecting data and then some human person has to make the decision. It is the automated collection of data and also the automated decision making and also the automated executions of decisions. The fourth category, I would say, are the visualization technologies and simulation technologies. So in addition to the decision support systems, there are now multiple types of hardware and software with which you can sort of move around in areas that actually do not exist. These are generated areas. So that is with the help of decision support tables, for example, with hologram tables, with displays, which you can see on your face. And with that, you can see objects in 2D, 3D, 4D, and you can generate so-called virtual, augmented, immersive, and mixed realities. And the advantage of those technologies is that you do not just see a picture, but you can actually visualize, feel, touch, even hear, perceive dynamically situated environments. So these are new technologies that are arising, coming especially from the gaming industry, but they become increasingly useful for spatial planning, for trying to find out what a particular area would look like, how it would feel, how people perceive it. You could do all sorts of tests with that. So essentially these technologies, they construct new data models and convert them into dynamic images and other types of representation, which can then be applied to analyze a number of phenomena. And the last category of geospatial technologies are the data management technologies. Traditionally, we think of that as regular spatial geodatabases, which have remained more or less the same for the past 20 years. If we compare the earlier databases of access to the geodatabases of Oracle, essentially they look pretty much the same. Relational databases that you can query and search with SQL statements, formal language to query what sort of data relate to each other and how they relate to each other. But now, in the last couple of years, you see the emergence of non-relational databases, such as graph stores, column stores, document stores, blockchain architectures. And these are databases that structure the data in a completely different way and that try to overcome some of the difficulties and maybe limitations of traditional databases. With traditional databases, it is very easy to query, but it's very difficult to find patterns and clusters of patterns. And especially graph databases, they can find those patterns in an easier fashion. And similarly, with relational databases or traditional databases, they heavily depend on access regulations. Very often the database is centralized in one location and only the one with the password can access the database. Now, to overcome that bottleneck, blockchain has been developed and promises to provide a solution. These decentralized architectures, these are accessible anywhere, these are generated anywhere, so you're not dependent on a central repository or a central custodian of that database. You can access it basically from any place at any time. And then let's look at some of the examples that fit in land. So when talking about these geospatial information technologies, what sort of examples do we have? Detecting locations, we have done a study, for example, to detect pastoralist spaces. So locations where herders and pastoralist people actually are, so statically and dynamically. Also detect energy, water, food systems. That's also a study that was done. Where do people need how much water at which particular point in time? So typically integrative use of technologies to find typical land questions. For location technologies, we've done a study, for example, on the renovation of the geodetic system in a particular country. Traditionally, this was done with traditional conventional survey technologies, actually with trig beacons, and then with tachymeters or theodolites. Nowadays, most of those georeference systems or references are based on kinematic GNSS systems with continuously observing reference systems. So essentially you have a number of fixed georeference systems in the country, and you connect to those sort of which you know the exact coordinates, and with a GPS or a GNSS system you can connect and then georeference your observed data. And that is much easier and nowadays also much more accurate than with the traditional surveying technologies. Other ways to look for data is, of course, remote sensing. The traditional remote sensing was mostly optical remote sensing. Most of the Landsat data, and now we just had the launch of Landsat 9, we're still using Landsat 6, 7, 8 were still optical technologies. Now we see more SAR technologies, so active sensors that transmit a signal and then get the signal back. And the difference between that is that the optical technologies of remote sensing, they provide indeed, they can be very accurate, but they provide a number of pixels continuously, whereas the SAR technologies, they provide point clouds. These point clouds, they get more and more dense. So the way of processing is obviously different, but the accuracy of the data is much higher than with the optical technologies. So especially for topographic mapping, for geomorphologies, for shapes, these sort of SAR technologies become much better. And we see an increasing number of applications also in the field of land management for these type of technologies. Then there is the smart technologies, and that's definitely the future, especially for the generation of scenarios and the comparison of scenarios. We can, for example, run different types of scenarios. We take a decision to invest in a lot of green, or we take a decision to invest in a lot of build-up. What are then the effects over time for deforestation, for the need for energy, for example, the need for groundwater? We can simulate that and run that with new technologies. And also automated detection of changes. We see, for example, the result of the dissertation of Krommelink, which was on the automated detection of new boundaries in informal settlement areas. So without going to the field, you can actually detect, and without sort of going through every image, you can automate the process of detecting boundaries and then record those boundaries immediately. So machine learning allows you to do that. And in visualization, we see lots of developments. The idea is really to visualize, feel, touch, and hear, and play around with dynamic and simulated environments and construct new models. Here we see, for example, an image from identifying the distances between workplace and residences. And the idea about that is to identify where should we locate new infrastructure, where is the time and the difference. Database, you can get lots of satellite imagery. You can get all sorts of thematic information from repositories like SpaceNet, Deep Globe, Big EarthNet, and Open Cities project. So these types of information, usually in the form of coverages of remote sense data, satellite images, are most of the time available for free, and you just have to insert them into the system that you make use of. A number of other data sets, where to retrieve geospatial data. Here is just a selection of data that you want to make use of for any sort of application. These are repositories most of the time that offer free. So please have a look on that and see if you can find the applications of your interest. For the case of extended and immersive and mixed realities, as I was saying before, it is not just creating simulated environment, it's also creating new feels and perceptions of the environment itself. So the technologies do therefore not only envision alternative scenarios, but also alternative realities. How do you look at the situation? And I want to mention here two examples. The Holy City, that is an example where they have mapped and modeled the entire city of Sydney, and you can walk through that imagery without going to the field. That was a study done by Mr. John J. Lee. 2021 was completed, a dissertation, and he came up with a number of recommendations how to do that, how to see land tenure without going to the field. So how can you derive land tenure with some basic information about the land tenure, some basic information about the spatial shapes, and then some basic information about clustering, spatial phenomena, and spatial objects. So here are some examples of that study, and here is a list of the proxies that he suggests should be used in order to derive the information automatically and then seeing non-registered tenure. So we can generally say that what is very promising for land management in the geospatial technology world is the connection of BIM to GIS that can be used or that can already be seen in the use of 3D clusters, extended reality technologies, blockchain and graph technologies, and big data analytics. And we see already the emerging examples of that. What is still complicated is embedding digital twins. So technically it seems to be possible. And also the use of artificial intelligence, technically it seems to be possible, but there are still some fundamental problems with it. The legality, for example, also the potential misuse of the data of especially virtual environments and immersed environments. And finally, there are also some ethical considerations in relation to privacy and surveillance technologies. So in summary, which technologies are available? I would say a broad range of technologies are available, more and more become available. What is already being used? As said, machine learning, LiDAR is being used, BIM is being used. And what are, let's say, the needs for the future? We still need more active stakeholders. We need an uptake of those technologies by all sorts of private companies. And we also need more consideration for the ethical and maybe privacy problems that are there. Thank you for your attention. and hope to talk to you again.
Okay, thank you, Prof. Walter, for the video presentation. This is the actual material, I guess, and I noticed several important things that GIS is not only for a tool for mapping, but more than that, GIS can be as a decision support system or planning support system. So this is for worthwhile for land management and geospatial information system, such as how to connect people and land, and so land conversion in rural region, for example in Germany, like Prof. Walter said, and then they contribute to relevant and appropriate solution to avoid negative effect of land take, such as maybe land adjustment or redivided in the several land management system. So I also interested about the smart and artificial intelligence technologies, let's say AI, machine learning, to predict not only for urban growth, but also for infrastructure and prepare the proper decision for urban and regional land management. Let's say about the 2D, 3D, 5D, using big data, visual analysis, blockchain, etc. For the land management. And also the other interesting thing is data acquisition. Prof. Walter said about satellite-based accuracy. Let's say about the optical remote sensing or SAR remote sensing. It's a great part of technical remote sensing, and then about GNSS for some acquisition in the location. And then about some application for land tenure. There's a lot of application about land tenure that provide several things about how we can use geographic information system to manage and to provide proper management in land use planning. The last but not least is land management and using GIS can provide sufficient and affordable space for everyone. This is the clue for Prof. Walter de Vries' presentation. Thank you, Prof. Walter de Vries. We can move to second presenter. Before that, we have to give applause for the Professor Walter de Vries. Okay, for the second presenter, I would like to ask Professor Dr. Renat Imam Bukhari. Sorry, you have to unmute your mic first off. Okay. Yeah. Are you ready to present your material, Prof? Prof. Imam Bukhari will share about his research, everything about the GIS implementation in land management, in disaster, and several experiences about how GIS will be such as worthwhile things in managed spatial and for rural and regional planning. So time is yours, Prof. Imam Bukhari. Hello.
Can you hear my voice?
Sorry, louder please, Prof. I can hear your voice clearly.
I think you have heard you yeah, so my presentation, I think perspective. An example of implementation, so how use the support.
Sorry, Prof. Imam. We cannot hear your voice clearly here. Can you?
Test.
Yeah.
Okay.
Yeah.
Okay.
Better. Yes, better.
Yeah.
Very clear.
Yeah. Okay. The theme of this study, this research, is about the dynamics of spatial in the area of suburban. Yeah. And I will present this material in 6 parts from introduction until conclusion. Well, as I told you before, that this research has provided 3 articles, and what I would like to explain today is actually this first article that has been published in a journal, international journal, and the other 2 are still in the process of review and also submission. Yeah, this is the article. So after this session, if you'd like to read more about this topic, so you can directly read from this article. You can download the journal. Okay, the introduction. Yeah, this study began with the issue of urbanization. As we know that urbanization is not just about migration from rural to urban, but it is more than that. It is about the lifestyle also, which transform from rural to urban. And there are some indicators of urbanization, such as the increase of settlement density, increase in commercial industrial activities, and also rapid change of land use, and also an increase of commuters, where the people from the surrounding city go to the city to work, and then in the evening they go back to their home. My case study here is located in Pringapus. Pringapus is a sub-district located in the Semarang Regency or Kabupaten Semarang, and there is a dramatic increase of built-up area there because the development of some industrial activities. And in this location, what is so-called desa kotasi, an urbanization process in the rural hinterlands occurred. And the cause of this urbanization is actually the establishment of some big factories. Most of them are garment and textile factories. The question arise from this study is, how does the urbanization in an enclave rural area, because the location is unique. It is quite far from the main street, the regional road, but from this like isolated location, or I call it as an enclave location, urbanization grows. So this enclave area, through an industrialization process, empirically result in the change of land use and livelihoods of the rural communities. So the study is based on this question. From the study, we can get 2 benefits. The first is to enrich literature relating to this topic. And the second is to give reference from local governments, so that they can consider the results of the study when they handling the similar cases. I mean, when they handle development in an enclave locations like what happened in Pringapus. There are some literature review, as you can see here. First talked about urbanization, and then talk about industrial activities, industrial development that can generate enclave region in the peri-urban areas. And then the enclave influences changes in socio-economic. And then urban expansion to the periphery potentially influence the characteristic of the region. And further questions about the sustainability of the agricultural activities. Because previous studies show that this kind of development can endanger the agricultural activities, which in turn can harm the sustainability of food security. And the last is about urban expansion that can increase spatial gap due to the presence of large industries in the suburbs. Based on this literatures, we developed some variables and indicators which then are observed its suitability with what's happening in the field. This is the methods. Primarily, we use descriptive analysis of statistics and supported by satellite imagery analysis using geographic information system. There are two stages. The first is to analyze the land use change, and in this analysis we use GIS and also image processing, part of geomatics. Those maps were developed from satellite imagery in the years of 1990, 2006, and 2018. And the second stage aims to analyze local socioeconomic and environmental changes based on the information from the sampling. So we did a questionnaire survey. We asked 100 respondents, randomly selected from the population there, with the criteria like this. The population is the residents over the age of 30 who had lived in the area for more than 15 years. And according to the data, there are about 7,000 plus persons there. And then from this, we select 120 respondents, because this number are extended by 20%. So the final respondents were 120. This is the spatial distributions of the respondents. You can see we used here clustered random sampling. This area were divided into seven clusters, and then from each cluster we put samples depending on the number of the population in those clusters. And this is the spatial distributions of the respondents. You can see here. The black one here are actually in the industries, the factories. And you can see this location is quite far from the main street, the regional network here. So here. Okay, this is the general characteristics of the respondents. You can see here. This is about the duration of their stay. And then this is the family. This is the level of educations. You can see that most respondents usually graduated senior high school or less. Only a few of them had a diploma or bachelor degree. Okay, now this is the result. This is the pictures of land use change. You can see from 1990 to 2006, there is a growth of there was a growth of industries, factories here, and it become bigger and bigger, the area, and also the built up area here. The built up area here means residential areas except for industry, and the other are non-built up or open space or yeah, agricultural land use. Okay, and this is the spatial plan of Pringapus subdistrict. You can see here this area was actually not planned at the beginning, but after several years, the government of Semarang finally determined that Pringapus, some of areas in Pringapus were allocated for industries. This is for industries. And since then, the area developed, and also housings, new housings, I mean developer-based housing grew there, and yeah, it seems to form what you call this sketcher, sketcher dispersed in this area. Okay, this is the change of land use. In this table, we can see how the increase or decrease of every land use. We can see here that the industry significantly grew, and non-built up area, especially the agricultural land use, decreased. It's a minus. Following the new residence area, trading facilities such as kiosk shops and modern retail stores were established, as well as other facilities. Yeah, it's a normal, I think, because when there is a residential area, so it will always be followed by other activities, other supporting activities for the residential area. Few flats were also built. This is very interesting, because as we know that in Indonesia, flats usually just developed in big cities, yeah, or in very open area. But in this location, which we call this as so enclave locations, there were also some flats developed there. Yeah, to meet the needs of industrial workers housing. Okay, this is the opinions of the respondents about the land use change. You can see here that most of them agree was industrial activities, and they were also agree that the settlement pattern caused by the industry, the change of settlement patterns, and yeah, more than 50% also agree that there were no negative impacts to the environment caused by the land use change. Even some of them also stated that the negative impacts occurred then. And lastly, most of them also agree about the undisturbed feeling due to the land use change. So only few of them, less than 20% of the respondents said that they feel disturbed about the changes of land use. And as for the types of works area, you can see here there are significant changes. Agriculture that were previously dominant there, at present it is just about 7%. And there are many new works areas grew in this location, like trade, industry, lodging and food service, repair service, and so on. Yeah, this is the diagram to show the changes of employment here. We can see here, for example, there were many businessmen persons, and yeah, it is actually the industry, home-based industries that has relationship with the big factory. So many local people use some materials coming from the factory, and then they make handicraft. As for the income, we can see here there were actually significant increase in income of the populations there. Yeah. You can see here that after the development of the industry, their income grew significantly. And as for the facilities, we use here the road conditions as the indicator. We can see that the quality of road also improved, yeah, indicated by the increase of length of pavement road. And as for the community organizations, there were also found some new community organizations, usually relating to micro, small, and medium enterprises. And one of the interesting things is that the organizations of youth community, famously known as Karang Taruna, seems to be disappeared right now. And labor community and also merchant community grow significantly also. This is the opinions of the respondents relating to the social changes in the area. We can see here that the local residents usually have a good relationship with the migrants, and they also get new knowledge and skills from the migrant. And that's why the communications are also the kinship with the migrants. I think it is an important capital that should be maintained by the government. As for the environmental change, we can see here that most respondents stated that there was just little problem with the environmental problems after the industrial development. They still feel that it is still okay, but only a few of them, especially the residents living near the factories, felt that the water, yeah, that usually they come from directly from the soil, have bad quality of water, and for that they have to buy water from the what you call this water productions like aqua, something like that, for drinking water. This is the discussion. We found that the urbanization process in that area was actually in situ. It means that urbanization is not caused by significant migration from outside area to that area. Even there were also some migrants, but the change was not mainly caused by that migrants. And then the location was an enclave and far from the city center. The industrial activities grew in the area without support of transportation, because as I thought before that the regional road was quite far from this industrial area. It then affected the local indigenous people both positively and negatively in social, economic, cultural, and environmental ways. As for the housing pattern, the in-situ urbanization brings changes in settlement patterns. The change appears in the architectural design, and also the type of settlements, which were dominated by kampung settlements, but it has now started to develop many developers, small scale developers, to build several units of houses there. The pattern of housing dispersions has also changed from being scattered into a more compact pattern, especially in the area located close to the factories. Migrant workers increase the demand for accommodations and housing. Yeah, it is by nature they need house. Yeah. The emergence of developer style housing on a fair scale and flat type of housing estates, that is also unique. A unique thing appears in that location. Local people provided rooms for rent and boarding house for the migrant workers. Segregated settlements patterns. There are urban settlements close to the factories and the rural settlements further away from the factories. And this is about the relationship between the migrants and the local people. Relationship and social closeness between the local people and the migrants has positive impacts arising from the locations being far from the city center. So I think the enclave locations make them more closer and closer between the migrants and the local people. And the role of community organizations such as entrepreneurs, laborers, and merchant communities should be optimized, because it can avoid many negative impacts relating to social cohesiveness between the local peoples and the to have learned new skill from and expertise from the migrants. As for the environmental impacts, the people felt that they have no perceived negative impacts. Only a few people living close to the factories feel difficult in obtaining drinking water, as I explained before, and they prefer to remain in their current home as long as they were able to obtain the social and economic benefits arising from the existence of these industrial activities. And for the future agricultural activities there, I think, yeah, we found that there could be a problem in the future because there is reductions of your community's interest to be a farmer. So if this continue, there will be a shortage of farmers, which may in turn endanger the national security. And for the conclusions, we turn here 4 points. The first is that urbanization there is in situ, which cause to changes in spatial and socio-economics, and there is an indications of environmental degradation, but benefits to the people is more important for them. And then excellent interaction were established between the local community and the migrants. So it allows skills transfers and the locals more resilience to face the urbanization process. And lastly, the local government is supposed to strengthen as a kind of recommendation. Yeah. So local government is supposed to strengthen the community organization's role to optimize the mutually beneficial relationship between locals and migrants. That's the conclusion. And thank you, Pak Anang, for this presentation, for this opportunity, and I hope that it can just complement with what Pak Walter has explained about the comprehensive knowledge about GIS applications for land management. Thank you, Pak Anang.
Okay, thank you, Prof. Imam Bukhari, for presentation and material, I guess. And this is the interesting topic about the in-situ organization and what's so-called enclave management area that change the activity and the social economic condition as one of benefit the Pengapus area, and then the socio economic culture change after the urbanization process and so-called in-situ urbanization. Is in-situ, and in bahasa di situ berarti. In situ urbanization. So Prof. Imam also shown the analysis about the GIS implementation. It was applied for spatial temporal analysis, like for example the change between several times of year, 1998 and 2008 and then 2020. It's very useful to land management, especially in manage the suburb area, like the suburb area in Pengapus, Semarang Regency. Okay, please give applause for Professor Dr. Renat Imam Bukhari for his presentation. Okay, we have to move to the question and answer session. And please, for the all participants, you can propose your question to two presenters, Prof. Walter Timo de Vries or Prof. Imam Bukhari, or both. It's okay. 3 questions from the first Q&A session. Anyone? Maybe I just looking for your question in the chat meeting room, but there are no one propose the question here. Okay, maybe one of you can propose it directly. Please say your name and propose your question clearly and for whom it addressed.
There are 2 people raising hand.
Okay, the first one, Mr. Aulia Rahman Hasibuan. Okay, please open your camera. Can you open your cam, Mr. Aulia?
I'm sorry, but actually my camera is kind of broken. So.
Oh, it's okay. It's okay.
Okay,
just
thanks.
loud your voice and then pose your question clearly. So
thanks a lot, Pana.
Okay.
Okay. First, I would like to introduce myself. My name is Aulia Rahman Hasibuan. As a student of Urban and Regional Planning di Ponorogo University. It's a question for both Pak Imam and Professor Walter. First, sehr geehrter Professor Walter, our honored Prof. Imam, and our honored all of our lecturers. Okay, I would like to ask about these sayings. Once the old says that the wealthy people getting better off, they get more wealthier. As we can see that having land on your own has become a pride nowadays. And by the time the real estate business has become a pit of money. By the presentation of Professor Walter, there's a say that this land management creates sufficient and affordable places for everyone. If we create a line between the land management and the social, people are getting selfish. The more money you have, the more feelings you get to afford many stuffs like lands, buildings, and others. So the question is, how about your perspective about that? What can we do to get a limit of this social perception? Can the GIS solve these problems? Thanks a lot.
I think this is the difficult question. Okay, the second question from Intan Hapsari Surya Putri.
Good afternoon, Prof. Walter and Prof. Imam. I would like to
Louder, please, Mrs. Intan.
I would like to ask the question, especially from Prof. Imam, because I really interested with his presentation related about digital urbanization. Yes, from the presentation of the process of in-situ urbanization, we know that it can bring positive impacts to the community. Like there are a lot of benefits that community gets from the development. The result of this study, we know that in case of in-situ urbanization, the local community receives many positive impacts to the community, like one of the increase of their welfare. Yes, even though they were less aware of the potential experimental damage in the location. Like we know that since there was significant increase in the job area, like in your presentation from the agriculture previously almost 80%, and then come to the less than 10% in the area. Yes, that especially become to the built up area in the like factories. Do you think that it can lead the development? It can lead to more environmental problems in the future in the area. And how about what do you think about the sustainable development in the region, Prof? Thank you.
Okay, good question. Thank you, Pak Aulia and Mrs. Indan Hapsari. The first question for Professor Walter de Vries, that's about the wealthy people and wealthier people can be selfish in land management. How about the GIS can analyze or can help us to identify like the land channel for the several people? Okay, Prof. Walter de Vries, can you answer the question from Mr. Aulia? Yes, he has a problem in his connection. Sorry. Okay, maybe from the second question, Prof. Imam, can you answer the question from Ms. Intan Hapsari? Okay,
So
Prof.
I can hear I'll try to answer the first question from Aulia. As I informed before that we see GIS here in urban regional planning as a tool that can help us to observe or to study certain phenomena or certain cases in urban and regional planning. And what I just explained is one of part of a series of study. So unfortunately, I cannot explain the output of the second year of the study. It is about gentrifications. And in this study, I think we can see more about how the interaction between the local people and the migrants in having a house. You know that we see that in Indonesia there are many conflicts about land acquisitions and also the interactions between the locals and the migrants. And for Intan, yeah, again, in that study, I mean the first year of study, we still focus on the spatial dynamics in an enclave area. And in further studies in the second year and third year, we talk about whether gentrification is occurred there. And the third year talked about the impacts of urbanization, particularly the establishment of many factories there, to the role of women workers in the household. And unfortunately, it is still in the process of submission, so I cannot explain the outputs in detail. But it is very interesting. It was very interesting that that how the women workers, the locals, got benefits from the establishment of the development of industrial activities there. Okay, we can discuss more after the session. Thank you, Pak Anand. Sorry, suaranya nggak kedengeran tadi soalnya. Sorry, I got problem with my equipments.
Okay, thank you, Prof. Imam, for the answer. Hopefully, it's enough for Intan, Ms. Intan. If you have a further question or further discussion, you can ask Prof. Imam privately or directly. Because he is your promoter now. Okay, Prof. Walter de Vries.
Yeah, my apologies. I just wanted to react to the first question. There was a question of fairness and appropriateness. What I want to say is that land management should not just to for the rich and deprive the poor. Actually, there's various ways in which you can optimize and
Sorry. Okay, maybe Prof. Walter have problem again with his connection. Maybe from the second session of the question and answer session, anyone can propose the question? No one? Or I have to force some people to get the question. Chandra Margarina maybe, or Pirian Pradana. Maybe you have something to discuss with Prof. Imam or Prof. Walter. No? Okay, if there are no questions anymore, I will give the explanation. Okay, Pak Aulia Sibuan.
Oh, okay. I'm sorry that I asked a lot of questions.
No problem.
Okay, maybe this one is for Prof. Imam. Well, we can see that in Indonesia itself, the land tenure has become a problem at the moment. There are many illegal buildings that appears without any kind of assessment to the government, like EMB dan lain-lain. So perhaps the question I would like to ask is how we get the izin, dalam kutip izin, to get more easier like that.
Okay. Yeah, I think building permits is not always easy in Indonesia. The Ministry of Land and have started to organize the detailed plans to be accessible for everyone. I think the detailed plans can be used as the basic for building permits in Indonesia. For example, if you would like to build a house, when we search the plan and we know that it is allocated for residential area, I think it should be easier than if you would like to develop in other area that were determined for other purposes. And as on the basis of my knowledge, the policy of our government now is to open the informations about the plan. And by doing so, we hope that investors will be interested in investing their capital to Indonesia because the land status are clearer. I think that's my what I think about what is your question. Thank you, Pak Anang.
Okay. I think it's clear, Pak Aulia, the answer from Prof. Imam Bukhari. Okay, I guess there are no one question anymore. So I have to end this international lecture session. I hope it will bring many benefit for all participants, and I will return it to Ms. Intan. And don't forget, tomorrow we have the same session, the fourth session in the international lecture series with Prof. Nani Yuliastuti and Dr. Ing Asnawi Manaf. The topic is about the settlement, and if you have time, you can join it tomorrow at the same time, I guess, Mbak Intan.
Yes. At
Yes.
10 p.m. Pak.
Okay.
Yes.
Okay, thank you for the other participants, and sorry if I have a little or big mistake in bringing this international lecture series, and I hope it will bring many benefit for you, for our participants, and for us also in Urban Regional Planning Department. Thank you and see you later. Assalamualaikum warahmatullahi wabarakatuh.